everyone, welcome back once again to Cambridge Guru. We have already started our last chapter, complex numbers, and in the last video I introduced you the concept of complex numbers and how we write any complex number. A complex number can be written as a plus ib or x plus iy. So any complex number will have two parts. One is the real part and another one is the imaginary part, right? So let us solve some questions that involves complex number, or how we can write any given complex number in the form of a plus ib or p plus qi, right? So this example says that find the real numbers p and q such that p plus qi is 1 upon 3 plus 5i. Basically what we have to do here is that a complex number 3 plus 5i, this is in the denominator. So as a practice, you can say that we cannot write the complex number, or we cannot keep complex numbers in the denominator. Just like we do not keep any irrational number in the denominator, what we do is we rationalize that denominator, right? So same way we have to bring this 3 plus 5i or any complex number which is in the denominator to the numerator by multiplying the complex number with its conjugate, right? So if you have a complex number of the type a plus ib, so its conjugate is given by a minus ib, right? So if I have to bring this complex number from the denominator to the numerator, I have to multiply by its conjugate, which is 3 minus 5i, right? And of course we have to multiply both numerator and denominator just to keep the value of the complex number as same, right? So let us write this in p plus qi form by first multiplying this with the with its conjugate. Okay, so I have p plus iq is 1 over 3 plus 5i, multiplying and dividing by its conjugate. So let us say its conjugate is 3 minus 5i, and here also 3 minus 5i. Okay, so this turns out to be 3 minus 5i over, this is an identity, algebraic identity, that a plus b into a minus b, where value of a is 3 and b is I5, right? So a plus b into a minus b is a square minus b square. That means this is 3 square minus 5i whole square, right? That means this is 3 minus 5i over 3 square is 9 and minus of 5i square. 5i square is, I have to write this as 5 square into I square, right? Splitting this exponent to both the terms 5 and I. So here it turns out to be 3 minus 5i over 9 minus, this is 25. 5 square is 25 and I square is minus 1. Remember in the last video I gave you some basic, you can say, exponent of this I, that I is of course minus 1 root and I square is minus 1, right? So here I square is minus 1, so this minus and this minus turns out to be plus, so I will write this as plus 25. Okay, so a square minus b square as far as complex numbers are involved, so that I square will bring this minus sign or make this minus sign into plus sign, right? So 25 plus 9 is 34, so this is 3 minus 5i over 34, right? Separating this denominator to both the numerators, meaning that I can write this as 3 by 34 minus 5 by 34 multiplied by I, and in the LHS we have p plus I times q. So now if you compare any complex numbers, LHS, not LHS, in the LHS we have p plus iq, one complex number, and in the RHS there is a complex number whose value is 3 by 34 minus 5 by 34. So as we compare the x coordinate, as far as coordinate system are concerned, that as x coordinate will be compared with the x coordinate and y coordinate will be compared with the y coordinate. So similarly, if we have to compare any two complex numbers, so real part will be compared with the real part and imaginary part will be compared with the imaginary part. It is just like vectors, right? A vector has two components, right? So if we have watched our previous videos of vectors, so what we do in vectors is we compare the x component, means I component with the I component, j with the j, and k component with the k component. Okay, so similarly here real part will be compared with the real part. So this is that p is the real part here, so value of p is 3 by 34 and value of q is minus 5 by 34. Okay, this is p and q, right? Okay, so let us do another question. It says that express this complex number as a complex number in the form of x plus iy. So again, one complex number is in the numerator, another is the denominator, so we have to bring this to the numerator and write that in the form of x plus iy, where value of x and y we have to determine. Okay, so the same thing we will do here also, that 9 minus 4i over 2 plus 3i, this will be multiplied by its conjugate. Whose conjugate? Whatever is the complex number which is in the denominator. Okay, so this is 2 minus 3i and this is 2 minus 3i. Okay, so numerator will become 9 into 2 is 18. This is minus 27i. This is minus 8i. And minus 4 into minus 3 is 12i square, right? Plus 12i square, and I square will be minus. So ultimately you will get minus 12. And in the denominator we have again the formula of a square minus b square. So a square is 2 square minus 3i square. Now combining the like terms, real part means the terms which are not involving any I. So this is 18 minus 12 is 6, and combining the imaginary part, this is 27 and 8, which is 35. So minus 35i. Okay, over 4, and this is 3i square is 9i square. 9i square means minus 9. I square is minus 1 again. So minus minus will become plus, so it is plus 9. Okay, so this is 6 minus 35i over 9 plus 4 is 13. So value of x is 6 by 13. I can split this again as 6 by 13 minus I times 35 by 13. So x is 6 by 13 and y is 35 by 13. And remember, in the last video I told you that as far as definition of complex number is concerned, that if you are writing any complex number in the form of x plus iy, this x and y, these have to be real numbers, right? So as you can see here, x is 6 by 13, y is 35 by 13. Both of these are real number. It becomes an imaginary the moment we multiply this number with I. So this is your imaginary part. Okay, but as far as value of I and x is concerned, both the values are real number. Okay, let us do one more question. It is very important one, that find the two square roots of 8 plus 6i, right? So finding the square root, the method you will apply is this: how to find out the square root of a complex number, right? So if this 8 plus xy is having any square root, so that square root will also be a complex number. You cannot get a real number whose square root or whose square is a complex number, right? So the answer of this means the square root of a complex number will be complex number, and if it is not, by somehow, if it is not, then you will get ultimately the imaginary part as 0, right? So for now we will consider this, that any complex number whose square is complex number will be a complex number. Okay, so writing this x plus iy means writing 8 plus 6i square root in the form of x plus iy, right? Ultimately x and y we have to find out, right? So how we can find out the value of x and y? The method is, the moment you see a square root in any equation, what you do is you square. Okay, so let us square on both the sides. You will get, let us square these. So this is x square plus iy square, I square will become minus, and you will just have a y square with a negative sign. So this is minus y square. So this is a square plus b square formula plus 2ab, right? So plus I times 2xy. Okay, this is a square plus b square plus 2ab formula, a plus b whole square, right? And in the RHS, this square root will get vanished. So you will just have 8 plus 6i. Okay, now since in the left hand side, since x and y both are real number, as I told you, so this x square minus y square will again be a real number. So this real number can be compared with the real part on the RHS, right? And imaginary part can be compared with the imaginary part on the RHS. So now here I have two values. One is that two equations basically. So x square minus y square is equal to 8 and 2 times xy is equal to 6. This is real part comparison and this is imaginary part comparison. So from this I get value of xy as 3. Now I have two variables and two equations. One equation is this, second equation is this. I can solve this by, let us say, substitution. So from 2, if I substitute value of y as 3 over x, from this equation I can get y as 3 by x. Putting this y equal to 3 by x in equation number 1, I get x square minus 9 by x square is equal to 8. Y square is 9 by x square, right? Simplifying this, this is x raised to power 4 minus 9 by x square is equal to 8. That means this is x raised to power 4 minus 8x square minus 9 equal to 0, just after simplification. Okay, transferring the term, multiplying this and then transferring to the LHS. Right now, let us assume that let x raised to power square is some another variable, because this is can be reduced to a quadratic equation. Right, just by looking at this, it does not appear to be quadratic. But if I substitute x square as another variable t, so this will result in a quadratic equation in t, which is t square minus 8t plus 9. Sorry, no, plus 9, it is minus 9. Minus 9 is equal to 0. Okay, I can simply factorize this. That means this is t minus 9 into t plus 1 is equal to 0. Solving this equation, I get value of t as 9 and t as minus 1. Means either t is 9 or t is minus 1. Putting back the value of t, which is x square. So x square is equal to 9 or x square is equal to minus 1. Now since you can say that, sir, this x square equal to minus 1 is also possible, but that is not the case, because here x is not an imaginary number. Remember, whenever we are writing any complex number in the form x plus iy, these x and y have to be real. Okay, but here have to be real, right? So if you are considering x square equal to minus 1, you won't consider this, because x then turns out to be a complex number. Okay, so meaning that we have to reject this equation and simply find out the value of x as plus 3 and minus 3. Now, the moment I get x as plus 3, value of y accordingly will be plus 1, and if x is minus 3, value of y is minus 1, using this equation. Okay, so here I get two values of x and y, that means two square roots. So you have one complex number as x plus iy. So either you use this one, because when x is plus 3, y corresponding y is plus 1. So one complex number is 3 plus I. And if you are using this combination, then second square root is minus 3 minus I. Please do not get confused that the second one will have to be its conjugate. No, that is not the case. It may come out to be a conjugate, but not always. Right? So this is not a conjugate of 3 plus I. Right? So these are the two square roots of the given complex number, which is 8 plus 6i. Okay. So I hope you enjoyed the video. A new assignment has been uploaded on the Telegram. right? And I will post that on the link of the Telegram channel, my Telegram channel, in the comment section, please, in the description box, sorry. So you can join my Telegram channel and see the assignment of chapter 4, which is differentiation. Okay, and other assignment are also there, right? Polynomials and algebra assignment is there, and log and exponential assignment is there, and third is your trigonometric assignment. Okay, so I think 3 assignments I have uploaded already on the Telegram channel. The same will be done on in this description. Okay, so I hope you enjoyed the video. See you soon in the next video. Till then, bye bye, take care.